Electrolysis, part 5. Continuing with aluminium oxide. What we should already know, aluminium, super useful, is very light, very strong, but when we find aluminium in the ground, it's as an ore, aluminium oxide. It's reactive with the oxygen. I don't want that, I want pure aluminium. That's why we need electrolysis in the first place. Now, just like all types of electrolysis, it's either got to be molten or dissolved. This one is molten, we melt it. Now, the additional piece of info you need to remember is we add in a substance called cryolite that reduces the melting point. Okay, so we've got all that, but what actually happens at the electrodes? This is where we have to write out half equations. So, aluminium is a 3+ ion. You can work that out by looking at the electron structure, but for now, let's just focus on the fact that we know it's a 3+ ion. For it to become normal ion, a normal atom, it will need to gain electrons. And because it lost 3 electrons and became positive, to become normal aluminium, it's going to need to gain 3. And I'll produce aluminium. And if you remember, oxidation is loss of electrons, reduction is gain. So the aluminium has been reduced. Okay, oxygen is an O2- ion. It gains 2 electrons whenever it becomes an ion. Now, when you show losing electrons, do an arrow first, electrons, and then oxygen. Now, oxygen is a atom that always exists as a pair, so you always will make 2 each time. Okay, now I've got to balance this off. So I've got 2 oxygens at the end, so that means I would have needed 2 here. Okay, now what about the electrons? How many are you going to lose? Well, I've got 2 lots of O2- ions. So I'm going to need 4 electrons. And then finally, oxidation is loss, reduction is gain. The oxygen has been oxidized.